सो गाइस, आज हम लोग फिर कुछ बिटसेट के क्वेश्चन करने वाले हैं। तो बिटसेट के एक्चुअली पार्ट 1, पार्ट 2, पार्ट 3 आप लोग देख चुके हैं। पार्ट 4 देखते हैं। इसमें भी हम बिटसेट के कुछ क्वेश्चन, ज़्यादातर मैग्नेटिज्म के क्वेश्चन में लेके आया हूँ। तो इसको करते हैं। बिटसेट का एग्ज़ाम अभी आप लोगों का आने वाला है, तो दिस विल बी वेरी हेल्पफुल फॉर यू। करेक्ट। तो आइए चलिए पहला क्वेश्चन देखते हैं क्या है। पहला क्वेश्चन आपकी स्क्रीन के ऊपर है। For the arrangement as shown in the figure, the magnetic induction at the center is, तो हमें बेसिकली क्या है कि सेंटर पे मैग्नेटिक इंडक्शन निकालना है। आप लोगों को ये पता है कि सपोज आपका कोई करंट कैरिंग लूप है एंड इसका अगर रेडियस ए है, करंट कैरिंग कोई आपका लूप है, सपोज ये आपका आई करंट है इसमें। हम्म, तो इसके सेंटर पे क्या मैग्नेटिक फील्ड होगी ये हमें पता है। सेंटर पे जो मैग्नेटिक फील्ड होगी बी, दैट विल बी बेसिकली म्यू जीरो आई अपॉन 2 ए। करेक्ट। यहां तक तो कोई प्रॉब्लम नहीं है। अब क्वेश्चन में बेसिकली क्या है कि ये सेगमेंटल कहना चाहिए, पोर्शन दिया हुआ है लूप का। करेक्ट। सो इसके लिए बेसिकली कैसे आप निकालोगे, तो आप लोगों ने ये भी पढ़ा होगा कि अगर कोई सेगमेंटल कहना चाहिए वो है, तो हमारा जो बेसिकली फार्मूला होता है बी, वो होता है म्यू जीरो आई अपॉन 2 ए एंड प्रोपोर्शनेट हम निकालते हैं बेसिकली थीटा अपॉन 2 पाई। फॉर द फुल सर्कल द एंगल इज बेसिकली थीटा। Here in this case, what is theta? Theta is basically 2 pi, or you can say 360 degree minus 90 degree or 270 degree. करेक्ट। 270 डिग्री को बेसिकली हमें रेडियन में चेंज करना पड़ेगा। रेडियन में हमें चेंज करना पड़ेगा। तो रेडियन में इसकी वैल्यू क्या हो जाएगी? रेडियन में हमारे पास इसकी वैल्यू होगी आपका, that will be equal to 3 pi by 2। करेक्ट। यहाँ हम अगर रख दें म्यू जीरो आई अपॉन 2 ए इंटू 3 पाई बाय 2 डिवाइडेड बाय 2 पाई। करेक्ट। तो ये हमारा कितना आ जाएगा? ये हमारा आ जाएगा म्यू जीरो आई, of course 3 will be there, upon then pi will cancel out, 2 2 to 8. So this is your answer. Correct? I hope you got this. Let us move to the next question. Next question is like this. If the resistance of upper half of a rigid loop is twice that of lower half, then magnetic induction. So here basically resistance is like this. Now this I, this will be divided. Figure should be like this basically. This. This I will be divided based on the resistance. So naturally this is 2R and this is R. Total is 3R. 3R means here it will go I by 3 and here it will go 2I by 3. It will go in the inversely proportional to their resistance basically. All these things you know. अब क्या करना चाहिए? अब आप ये देखिए कि जो करंट है आपका, जो ऊपर वाला जो करंट है ये वाला, अगर राइट हैंड रूल से अगर आप देखो तो दिस विल गिव यू द magnetic field like cross magnetic field, downward perpendicular to this thing. This is due to and what about this one? Here it will be dot matrix. Due to this one, here it will be dot 2I by 3. Correct? That means due to the upper half and due to the lower half, the magnetic field at the center is in opposite direction. Correct? The magnetic field basically it is in opposite direction. Correct? So here now let us see what is B I by 3 means due to the upper half. This is basically, you see, in the last we have seen the resistance is basically, it is not reduced, it is basically, it is given. Upper half of the rigid loop is twice that of lower half. That is, resistance is already given. I am answering your question only. रेजिस्टेंस जो है इस क्वेश्चन में अपर हाफ का ट्वाइस है इन कंपैरिजन टू द लोअर हाफ. and due to that the current which is going into the loop, that will be divided. Correct? And due to that division, upper half the current will be I by 3. This is your I. I current is going into the loop, and upper half will have I by 3 and lower half will be having 2I by 3. Now due to the segment, you know, mu 0 I upon this thing 2 into A. A is the radius and this is theta by 2 pi. It is the formula at the center of the magnetic induction at the center. Here basically theta upon 2 pi, basically it is your half the this thing is there, so it will become mu 0 I upon 2A into 1 by 2 pi upon 2 pi, or mu 0 I upon 4A. Correct. Now we have to put the value of I. So due to I by 3, the magnetic field at the center will be mu 0 I or I by 3, put it in bracket, here it will be 4A. Correct? And due to when I is I 2I by 3, then mu 0 will be 2I by 3 upon 4A. Now they are in, so net basically magnetic field at the center will be what? Net magnetic field at the center will be mu 0 upon I, you can say, this is your 4A, and here you can say 1 by 3 minus 2 by 3. Correct? And this will be basically your mu 0 I upon 12A. Of course, minus and plus direction has not been asked in the question, so don't bother about the sign. The answer to this question is basically mu 0. Hello, what do you want to? Hello, I'm looking. Let me answer this. Are you also taking any online lecture right now? I have not understood what do you want to say. Hmm? Online lecture means, or online coaching, or anything what you want to say. So this is the answer of this question. I hope you understood this. Let us now go to the next question. Next question is on your screen, and that is the Earth's magnetic field at a certain point is 0.7 Gauss, means B is 0.70 into Tesla. Gauss, it is given in Gauss, so we have to write it in Tesla. Correct? Now, this field is to be annulled by a magnetic field at the center of circulating conducting loop 5 centimeter in radius. So, at the center of a conducting loop, V0, you know, mu 0 upon I, that is 2 into A. A is the basically radius. So, these two you just equate and find out the current. Correct? So, here mu 0 I we have to find out, divided by 2 into radius of the loop is 5 centimeter, means 0.05 beta. This must be equal to 0.70 into 10 raised to minus 4 Tesla. Correct? Mu 0, you know. What is mu 0? Mu 0 is basically 4 pi into 10 raised to minus 7. If you put it, then this thing will come as 5.6 ampere. Correct? Here, basically, Earth's magnetic field at a certain, the value of the Earth's magnetic field is given. It has to be annulled, means it has to be neutralized through a loop. The radius of the loop is given. Then just equate these two magnetic fields and find out the current. Correct? Let us go to the next problem. What is this? Now, this is basically 3 circular concentric wires. Correct? Here, let us, this is one, this is second one, this third one. Radius here we are given, this is L, or 3 circular radii A, this is 2A, and this is 3A. carrying current 3I, 2I and I in the same manner. So here it is 3I, here it is 2I, and here it is given I. In the same manner means current is given in the same direction. Okay? What we have to find out? Find the magnetic field at the common center. So we already know the formula, that is B is nothing but mu 0 I upon 2A is the formula. So here, since the same manner means current direction is the same, that's why the nature of the magnetic field, the direction of the magnetic field at the center will also be same. So net magnetic field due to first loop, second and third. Due to first, what will be there? Mu 0. Mu 0 upon 2, you can A, I also you can. Okay, ठीक है. What we can do is, okay, this is basically here radius is A and current is 3I. Current is 2I plus mu 0 3I upon 2, and this is basically 3A. Sorry, it is not 3I, it is I basically. So let us take mu 0 I upon 2A. Let us take. So this is your 3 upon 1 plus 2 upon 2 plus 1 upon 3. So let us find out what is this. This is 1. This is, so this will become as 3. 3 means 3, 3, 9, 3 plus 1, and this will be mu 0 I upon 2A. So here it will be basically, answer will be your 13 mu 0 I upon 6. Correct? Let us see this one. Just go through this question, how to do it. The charge moves towards the center of a circular loop of radius r along its axis. So this is the charge which is moving here, and what will be the magnetic field? The magnitude of B along the periphery of the loop is, we know B, or here, we know B is nothing but mu 0 upon 4 pi, correct? Q or I into dl upon I cross dl, you can say r square. Here, if you see, what is your Q? Q upon T is nothing but your I. So you can, this can be converted into 4 pi Q into V. V means what is your this thing, dl upon dt. You can say dl upon dt or dq upon dt is your di, or this is basically, you can write it as V. So V cross R upon this will become R cube. Correct? Or this formula again can be simplified as mu 0 upon 4 pi Q V R sine theta upon R cube. Now R is what? R is this. This is your R. R is basically, this is your, suppose if it is at a distance of x, then x plus R, x square plus R square. I hope this is clear. So now we can write this as mu 0 upon 4 pi Q, V is there, then R sine theta is, what is R sine theta? R sine theta, if this is your theta, R sine theta is nothing but R. So this will become R. And what is R cube? R cube is basically x square plus R square. This is 3 by 2. Correct? So here your answer is basically This is your answer. Correct. Now let us go to the next question. A current carrying loop is free to turn in a uniform magnetic field. The loop will then come into equilibrium when its plane is inclined. Correct. So any loop is there. This behaves as a basically magnet. So there will be a magnetic moment like this. Magnetic moment is nothing but I into A. Correct. And what is torque? Torque is basically your mu B sine theta, where this is your B. B is what? B is the angle between mu and this thing. Correct? It's a basically cross product. This is your basically cross product. Correct? Now, when B and mu, they are in the same line, direction of the magnetic moment and the magnetic field, if they are in the same line, means theta is 0 degree, then it will have equilibrium. Loop will try to align itself in the direction of the magnetic field. Correct? When theta is 0, your torque is 0. Then it will be in the equilibrium. There is no doubt about it. Correct? Now, when theta is 0, then actually here it is not the angle of magnetic moment. It is the when its plane is inclined at. Now, if mu is inclined with the way theta, then what about the plane? Plane is this. This will be 90 minus theta, means when theta is 0, then plane will have the angle with the magnetic field as 90 degree. Correct? So here plane should be to 90 degree to the direction of the field. I hope that is clear. Correct? Now let us see this one. In a given figure, the loop is fixed, but straight wire can move. The straight wire will. Now here, if you see, this portion is nearer and this end is farther. Now here, direction in the loop, current in the loop is in the same direction as I1. That means here in between they will have attraction. And what about here? The direction is opposite. So then they will have repulsion. Now, since this distance is less, so naturally force of attraction will be more than force of repulsion. Correct? That means force of attraction is more than that means loop will move towards the conductor. Again, I am explaining. Here you have a straight wire conductor. Direction is this. You have a loop here. In the loop, direction of the current is like this, as given in the question. Since they are in the same direction, that means this portion will have force of attraction. Whereas if you see this current is, and they are here, if you see the current is in opposite direction. That means this portion and this portion you can say, suppose this is A and B and the wire, they will have opposite current. That means they will be having repulsion. This is, they will feel force of repulsion. But force of attraction, since this distance is less, here the point B is quite far away, that my force of attraction will be much more than force of repulsion. That means the loop will move towards the wire if the wire is fixed. If the loop is fixed, if the wire has to move, then wire will move like this. It will move towards the correct. Let us see this question. This question is very common question. In every exam, this kind of question comes. You already know what is the value of the speed of light, that is 1 upon root mu 0, and what is the speed of electric field vector and magnetic field vector, they are related as this. So here it will be correct. So this was all about today's lecture. How are the questions? You please let me know in the comments box. If you want these kind of lectures, this kind of videos, live videos, then please let me know. We will come with more videos like this. Okay? So till our next video, let us say goodbye. Thank you very much. Please do subscribe my channel, because as you know, we are bringing a lot of things on this channel and which is very useful for your exams, whether it is JEE Mains or JEE Advanced or BITSAT or whatever it is. Correct? So thank you very much.